Hey guys, it's Shaheer. Welcome back to another 5 Academy video. So today we're going to be going through and solving the hardest geometry problems that you're going to see on the ACT math exam. Again, the point of this is to cover and speed review some of these concepts because you're going to see these on just about every math test you take. Some form of these problems, you'll see these tests testing you on and these problem types repeating. Okay, so it's important that you understand these concepts to get through the middle and even the end of the test and not take too long on these problems. Now, I will say this video is part of a series. We did a video recently about the algebra concepts. So again, if you need help with those type of skills, check out that video. The next video in this series will cover trigonometry skills. Okay, so again, intermediate to difficult trigonometry problems will be covered there. We did the same for algebra in the previous video. Just some background information on plane and coordinate geometry. There's usually around 20 to 25 questions on the math exam specifically for this skill. So yeah, it definitely shows up a lot and it's very important to understand. So without further ado, I'm going to get started. I will also just scroll through the problems. So if you want to try them yourself before you go through and watch the rest of the video, feel free to do so. All right, so just going to finish scrolling. There's about 10, I believe. So definitely give them a go and see how you do. And then you can watch the rest of the video to kind of assess your performance, all right? Cool, let's get started. The graph of this function is in the standard coordinate plane. Which of the following transformations, when applied to y, could result in the graph of this? Reflection about y-axis, x-axis, or the origin? Okay, so what do each of these reflections mean and how do you actually do a reflection? So let's first just conceptually understand. So let's say you have a function, any function, like a quadratic function. Let's just say it looks like this, okay? That's your function. Now, here you have your x-axis. Sorry, that's your y-axis, not your x, right? And here you have your x-axis, right? So if I was to take a function and reflect it across the y-axis, what that would look like is, imagine the y-axis becomes a mirror and my new function looks like this. Okay, so I just took each point and I moved it across. These points come here, these points come here, these points come here, okay? Pretty straightforward. Now, similarly, if I do a reflection across the x-axis, I'm just gonna bring that function, pretending that the x-axis is a mirror and the function comes down with all those points reflecting over the x-axis. Okay, again, straightforward. Now, reflection about the origin is where you do both, is where you do this and then you go down again. So imagine I took, for example, my red one, and then I just reflected that across the x-axis. Again, just one more time. I would end up with this right here, right? Or, again, so here what I did was I did the red reflection and then I did the black reflection. Or you could do the purple reflection across x and then do the black going across the y. Okay? So the idea is you are doing both the x and y reflections to get to the reflection across the origin. And you can see that roughly, if I take this function and I do a mirror across the origin, you'll see that, it's opening down, which makes sense. And it's the same thing. It's just on the complete other side of the coordinate plane. All right, so that's what each of those things are. Now, how do you actually do those mathematically, like in a function form? Because we know graphically what it looks like, but functions and like in terms of writing it out from a mathematical perspective, how do we do this? So think of this as well. So f of x, if I want to do a reflection across the y-axis, I'll write it this way. Reflect across y. What you do is you take your f of x function and you turn it into f of negative x. That means that you take all your x values in the function and you turn them into negative x. Okay, I'll show you how to do that in a second. Now, to reflect across x, you take your f of x and you turn it into negative f of x. Okay? What this means is you take the entire function, you put parentheses around it, and then put a negative sign in front. And then you evaluate what that function looks like. Sorry, I should do it for this one up here. Okay? Now the last one, reflect across origin. Now remember what I showed you. When you reflect across origin, you're really just doing the x and then the y after, or the y and then the x after. So you're doing both. So you take your original function, f of x, and you do negative f of negative x. Again, it looks like it's really just a combination of these two, right? To get to there. All right, so again, let's just evaluate that now. So if I take this function, let's just say f of x is equal to 4x to the fifth plus 9x to the third plus x. And then I want to do f of negative x. We want to see if doing either of these gets us to this. Which one of those gets us to that, right? So if I do f of negative x, what that'll look like is 4 times parentheses. What I would do is take each of your x values, put a parentheses instead of that, and then put a negative x, and then put your exponent after. Okay, so don't just take each term and put a negative in front of it. Rather, do the parentheses, because you want to be very careful on how you do the sign operations here. Okay, again, we're going to do negative x all to the third plus negative x. And then let's simplify. This equals 4. Now, what's negative x to the fifth? A negative number to an odd exponent is going to give you a negative number. So it's going to be negative 4x to the fifth plus 9 times negative x to the third is going to be minus 9x to the third plus negative x is going to be minus x. So I end up with this, which actually matches here. So a reflection across the y-axis will be applicable, which means the answer has to be either A or D. Now D is saying reflection about the x-axis. And let's go through and see what that looks like as well. So if I do a reflection about the x-axis, that'll be, let's just write my starting form. 4x to the fifth plus 9x to the third plus x. Now if I do negative f of x, right, kind of like going back to what I talked about here, if I want to reflect across x, I take my original function and just put a big negative in front of it, in front of the whole thing, equals negative 4x to the fifth plus 9x to the third plus x. That equals, now I'm going to distribute the negative to each term, negative 4x to the fifth minus 9x to the third minus x. And you'll see it actually matches the reflection across the y. So 1 and 2 is your answer. Now again, you might be wondering, how does such a function exist where the reflection across the y matches the reflection across the x? It's actually, when you have cases like that, it's actually called an odd function. So for example, let me show you one just to get your brain thinking. So if I have my coordinate plane and I have a function, if you think of y equals x to the third, it looks like that, right? If I reflect it across y, I end up with this. And then if I also reflect across x, I end up with, again, if I'm graphing from left to right, I'll also end up with this. So your x and y reflections actually match each other, right? Because when you're going across y, you're just bringing all these points here. That goes there. And then when you reflect across x, you're just bringing these points down here, right? So it actually ends up being the same thing. And you can do the operation here. So f of negative x is equal to negative x to the third equals negative x to the third, right? And negative f of x is equal to negative x to the third again. So they're both negative x to the third. All right, cool. That was a lot of time. Let's go a little faster for the rest of the video. How many vertical asymptotes does the function here have? So what's a vertical asymptote? A vertical asymptote is any x value where it makes your denominator of your equation equal to 0. So for example, if I give you the function y equals 1 over x, obviously when x equals 0, this function cannot be solved because what is 1 divided by 0? Try plugging it into your calculator, see what it gives you. It should tell you it's undefined or there's an error, right? So for this function 1 over x, you can't actually solve it at that point. I believe the function, if you graph it, I'm not even going to graph it, doesn't matter here. Actually, it does matter, I'll show you. If you graph 1 over x, you can put it into your calculator just to kind of give yourself some background and learn. It will look like something like this. It should look like that if I have my graphing correct. The main point being at x equals 0, which is this vertical line here, you have an asymptote, which is the function does not actually exist at that point. There are just these points here, or these lines of this graph that go infinitesimally high and in the positive and in the negative direction. Okay, and those are asymptotes. That's what an asymptote is. Cool. So now for this function, obviously in order to evaluate what the asymptotes are, all I had to do is make the denominator equal to 0, and it told me, okay, x equals 0 is an asymptote. So you think, okay, let's just take this denominator and make it all equal to 0. And that does work, except you have stuff in the numerator that could actually end up canceling out with some stuff in the denominator. So we want to make sure that we factor everything in the numerator and everything in the denominator and then evaluate, okay? So let's go ahead and do that. I want to factor everything out. So is there any way I can factor the denominator further? Well, x squared plus 6x plus 9 can be factored, because if you think of factors of 9 that add up to 6, you have 3 and 3, right? So I could turn that into x plus 3, and then I have what's left, x squared plus 1. X squared plus 1 cannot be factored further. This is actually non-factorable. Okay, so that's my denominator. I'll just move it down here to make it a little more clear what we're doing, and write my numerator on top. Numerator is, I'm going to factor the 2 out of this one as well, so it becomes 2 over x plus 1, x plus 3. It's just best practice. Now you can see, obviously, you can cancel out an x plus 3. So that gives you 2 times x plus 1 over x plus 3, x squared plus 1, okay? So how many asymptotes does this have? Again, you need to just make the denominator equal to 0 now that we have everything simplified out. So x plus 3, x squared plus 1 is equal to 0. Just make each of these individual terms equal to 0. So x plus 3 equals 0. Obviously, x is negative 3 is your asymptote. And you want to, and basically what we're trying to say is that x cannot equal negative 3. If you put negative 3 into this function, you're going to get 0 for your denominator, which means the function is not defined at 0 at x equals negative 3. So we have at least 1. Now, this function here, x squared plus 1 equals 0. Let's try to solve it. Negative 1, x squared equals negative 1. Take the square root. X equals square root of negative 1, which you cannot evaluate either, which means this does not give you any asymptotes. If you actually were to graph x squared plus 1 equals 0, I think it would look something like this. There's no x-intercept, so there's no point where the y value equals 0. Okay? So you have one asymptote. That is your answer. Even though in your denominator, it looks like you have 2 factors of x plus 3, and you maybe are able to factor x squared plus 1. You might think, oh, it's 4 or 3. In actuality, it is just 1. Okay? So it's always important when you do these problems to simplify. All right, in this problem, a certain function is in the form y equals a sine bx minus c plus d. Which of the following is this equation with a period decreased by a factor of 1/9? So we know that the function for a period is 2 pi over b, where b is just the constant that is in front of the x. So for example, in this function, your period is just 2 pi over b, literally, because b is in front of the x. If I give you y equals sine of 10x, your period is going to be 2 pi over 10, because 10 is that number in front of the x. It's just pi over 5, right, if you simplify. Now, if I want that period to decrease by a factor of 1/9, so I'm going to be doing 1/9 p is equal to 2 pi over b times 1/9. That's going to give you 2 pi over 9b. And again, if I compare my function with the denominator of this, literally what you're doing is the denominator of your p equals 2 pi over b equation, that b value is literally your defining your period, right? So if I know that my denominator is now 9b, I could just go ahead and plug that back into the function, and I know that I need to have a 9b in my equation, okay? So if I go from bx to 9bx, I'm going to actually be decreasing my period by a factor of 1/9. So this is going to be your answer. Again, the relationship that I'm trying to establish is just that whatever this value is in front of the x, that's what you put into your period function, and that's what defines your period. So I could just take what my new period is, 1/9 p, take this denominator, assuming I still have a 2 pi in the numerator, which is, again, I do, and just plug that value, 9b, back into the equation, and I end up with option C. Pretty simple. Hopefully that makes sense. For what diameter value does a circle have the same value for circumference and area? Okay, so circumference and area, what are those? Circumference is equal to 2 pi r, which is equal to pi times diameter. Area is equal to pi r squared, okay? So we're trying to make the circumference and the area this equal. So pi r squared is equal to 2 pi r. If I divide both sides by pi, r squared is equal to 2r. And let's just bring that 2r over. So r squared minus 2r is equal to 0. Factor out the r. minus 2 is equal to 0. So I end up with r is equal to 0 or 2, right? So for radius of 0 or 2, which obviously a circle of radius 0 doesn't make sense. So for a radius of 2, you end up with the same circumference and area, which would be 4 pi. All right, that's for a radius of 2, diameter of 4. And that is the answer, diameter of 4, right? Because diameter is equal to 2r, which is equal to 2 times 2, which is equal to 4. All right, so again, just problems asking you to play around with the equations. A rectangular prism has 6 faces. 2 of them have an area of 1 meter squared, 2 of them have an area of this, and 2 of them have an area of this. Which of the following are the side lengths of the shape? Okay, so 6 faces. A rectangular prism. So let's just draw a rectangular prism just to visualize. It's going to make it a little easier. And I'm going to do one of these. Okay. So let's just label side length. So length, width, height. So let's just say length times width is equal to 1 meter squared, right? Let's just assign them. It doesn't matter how they're assigned, but let's just assign them. Let's just say width times height. No, we'll do width times height is equal to 12, and length times height is equal to 24, okay? So I have a system of 3 equations and 3 unknowns. What I'm going to just do is start plugging things in. So let's put everything in terms of W. So L is equal to 1 over W, H is equal to 12 over W, and we'll just plug L and H into this equation. So I get 1 over W times 12 over W is equal to 24. You see what I did? I took L, which is just 1 over W. I took H, which is just 12 over W, and I plugged them in for each of their respective terms here and made it equal to 24. So that gives me 12 over W squared is equal to 24. If I multiply W squared on both sides, W squared, it's going to be 12 is equal to 24 W squared. Divide both sides by 24. Half is equal to W squared. And if I take the square root, W is equal to square root of half, which is equal to 1 over square root of 2. So one of the side lengths has to be 1 over square root of 2, which means it's either C, D, or E. Now, as far as the other side lengths, let's just use, if I know W, I can just plug that into this equation and find L. So L times W, which is, L is equal to 1 over W, right? Let's just use this equation. It's easier. So L is equal to 1 over 1 divided by square root of 2, which is W, right? So that's just going to give you, if you do 1 divided by 1 over square root of 2, that's 1 over 1 times square root of 2 over 1. If you do the, dividing a fraction is just the same as multiplying by the reciprocal, right? So actually, just to make it simple, you can think of it this way too. So dividing by 1 over square root of 2 is the same thing as multiplying by square root of 2 over 1, which is just square root of 2 is equal to L. So I need to have a 1 over square root of 2 and a square root of 2, which means your answer has to be E. We'll just do the last term just to make things easier. So I know L, I know W, let's find H. So H is equal to 12 over W. H is equal to 12 over W, which is 1 over square root of 2. That's equal to 12 times square root of 2, which is 12 square root of 2. All right. Seems like a really weird problem, but again, if you think of it, you have 3 equations and 3 unknowns. You can find the area of each of those individual faces and make everything in terms of one variable, W, plug that into the equation that doesn't have W, and you can solve it because you have then one equation with one unknown, and you can apply that once you know that known or know that unknown, you can apply that over to the other equations and solve. Below is an octagon of which each side length is 8 centimeters. Which of the following is the area of the octagon in centimeters? Okay, so each side length is 8, right? So what I'm going to do, if I want to find the area, I want to split this into shapes that are more manageable. There's a couple ways to do that. You could do, I think the most logical way is, I mean, you'd think, okay, how about I make slices? But if you do slices like this, how do you find the area of just one? I know this is 8, but I don't know what this distance is, L, right? So it's kind of hard. But what if I do a top to bottom here, and I do another top to bottom here? So I have this middle section, which should be solvable. And then I have a section like this, from here to here. I have a section here, section here, section here. So really, I just need to find the area of 3 shapes. 1, 2, 3. All the triangles should be the same, and this, I'll just label all of them that are the same. So it's just 3 different shapes. Okay. So the easiest one should be the triangle. Okay, so we know that it's an equilateral octagon because all the side lengths are the same length, which means that this triangle is really just going to be a right isosceles triangle. So you remember, for a right isosceles triangle, if both of these side lengths, let's just call them a squared plus a squared is equal to 8. That's 2a squared is equal to 8. That's a squared is equal to 4, which is going to be a equals 2. Oh, sorry, it's going to be equal to 8 squared. So you can't just, I did my Pythagorean theorem wrong. This is Pythagorean theorem, by the way, right? So a squared plus, if you remember, a squared plus a squared is equal to 8. Right? A squared plus b squared equals c squared. So I just made b equal to a. A squared plus a squared equals 8 squared. Now, if this is 8 squared is equal to 64, right? So that makes, if I divide, so 2a squared equals 64, divide by 2, a squared is equal to 32. Take the square root of both sides, we end up with a is equal to square root of 32, which if you simplify that, it ends up becoming a equals square root of 2 times 2 times 2 times 2 times 2 is equal to square root of 16 times square root of 2, which is equal to 8 square root of 2. Sorry, 4 square root of 2, right? Okay, so what does that tell me? I have 4 square root of 2, 4 square root of 2. Now for this triangle, I have my length and width, right? Remember, the area of a triangle is equal to half base times height. I know the base and height are literally equal to each other, so area is equal to half 4 square root of 2, 4 square root of 2 is equal to half 16 times 2 is equal to just 16. Okay, so each triangle is equal to 16. So I'm going to replace these 3's with 16's in a different color. 16 units squared. Okay. Now, as for this section right here, I know what this side length is. It's 4 square root of 2, right? Because I just evaluated it for the triangle, and I know that this is equal to 8. So I can find the dimension just doing length times width. 8 times 4 square root of 2 is equal to, what's 8 times 4? 32 square root of 2. Okay, so let's just write that in for all of the reds. Sorry, for the 2's. So we get 32 square root of 2, 32 square root of 2. And that just leaves you with the 1. This is the most complicated because you have a 4 square root of 2, 4 square root of 2, and then you have an 8, and you have an 8. So if you add up this side length and multiply by that side length, you will get the answer. So 8 plus 4 square root of 2 plus 4 square root of 2. Sorry, I'm a little sloppy as I'm working really fast. All multiplied by 8 is going to give you the area of that giant thing. That is, it simplifies to 8 plus 8 square root of 2, all times 8. That's just going to give you 64 plus 64 square root of 2. Now you see I'm trying to avoid using decimals and just instead just writing it all in this form. You can really do it however you like. But at the end, I end up with 64 plus 64 square root of 2. Okay? Now add it all together. You will end up with, let me just pull up my calculator. So you end up with 16 times 4, right? It's 4 triangles, plus 32 square root of 2 times 2, plus 64 plus 64 square root of 2, right? That is my last term. So that's 64 plus 64 square root of 2 plus, oh wow, look at that, plus 64 plus 64 square root of 2. That simplifies to 128 plus 128 square root of 2. 128 times 2 to the half is 181 plus 128 again is equal to 309.02. Beautiful. That worked out quite well, right? Simplified really nicely. That's how you find the area of an octagon. Now, I'm sure there's a really good formula that you could use. I don't know that formula. So again, I kind of taught you, I just showed you the no formula method. All right, we have a few problems left. So let's get through these. Below is a rectangle with total length and width of 24 and 8 inches. including the rounded corners. The corners of the rectangle are rounded with radius 1 inch. Okay, each. What is the area of the round-edged rectangle? Okay, so how are we going to do this? There's two ways. You can find the area of the whole thing without, assuming it was just a normal rectangle without rounded edges. You could just find the area of this shape, and then you could subtract out this part right here, and you'd get your answer. That's probably the easiest way. The other way is to find the area of, the other way is just way too complicated. You'd have to find the area of what's inside here, and then add on this piece, this piece, this piece, this piece, all individually, and then add on the quarter circles individually as well. It's just more math. So if I do the first way, it's simpler. It's just one, it's really two operations. It's find the area of the whole thing and then subtract out the difference. Again, I'll just kind of outline it here. Let's just find the area of the whole thing first. Okay, so 24 times 8. It's 24 times 8. That's going to give you 192. Now, how do we do the subtraction? So each of these little radius corner things is, there's 4 of them. If you take 4 rounded corner things, you end up with a circle, right? With that same radius of 1. Now, if I just pretend for a second I have a square around this circle, and I know that the square has an area of 1, right? It's 1 times 1. I could just find the area of the circle and then do the subtraction between the square and the circle, and that'll tell me the difference as far as what is actually in this area. And then I could just take that value and apply it over to this and subtract it from there. So what is the area? Oh, actually this circle wouldn't be 1 meter squared. It would be, since the radius is 1, it's actually going to be 2 by 2, right? Because the diameter is 2. Radius is 1, diameter is 2, which means the square is a 2 by 2. That's 4 meters squared, or 4 inches squared, sorry. Okay, now area equals pi r squared is equal to pi times 1 squared is equal to pi, right? So if I just do, if I know the square has an area of 4, and I subtract pi, I'm really just left with what is in these corners, which is 4 minus pi. So if 4 minus pi is 0.85. If I just take 198, so area rounded, 192 minus 0.85, it's going to be 191, right? Or, I mean, you can see how they write it here. So I have to do 192 minus parentheses 4 minus pi, which is equal to 192 minus 4 plus pi. 188 plus pi. And that's your answer. So again, you can see with this problem and with the one before, dividing things into shapes is going to help you a lot. In the shape below, AF is perpendicular to AD. So AF and ED, sorry, they're perpendicular, which, okay, I can see that. FE is parallel to BC. Okay, makes sense. And AB is parallel to DC. That also makes sense. And AF and ED have the same length. Okay, great. What's the measure of CAB? CAB is going to give me this angle right here, okay? So obviously there's a lot of unknown angles. These, this, right? So it's about 5 unknown angles that we need to address. So the main way to do this is going to be, if you identify all the angles inside of this shape right here, you can derive the angles in this shape, okay? So let's do that. The way we're going to do this is, well, okay, once I know, I want to get this angle, right? If I just focus on this triangle, I want to get CAB, which is this angle right here. In order to do that, for the triangle, I already know this is 90 degrees. I don't know this angle. This is the main issue. If I knew that one, then I could just subtract 180 minus 90 minus whatever this is. Let's call it X. Let's call this Y. No, let's call this X and this Y, right? Now, in order to get this Y angle, I need to get this, we'll call it Z angle. In order to get Z, I need to have all the other angles in this shape solved. So let's do that, okay? Working backwards. So knowing what I know, it says AF is perpendicular to AD, to ED. What that tells me is that these two form a right angle, which means this entire thing right here is 90 degrees. So it doesn't really matter what this F angle and E angle are. The whole thing here is 90 degrees. So I can just model it as one big angle, okay? Or you could do it really, since it tells you all this stuff about parallel and perpendicular, you could really just, even looking at it visually, you can see that they're almost each 45 degrees. I'm not going to get into how to prove that for you, but a simple thing you need to know is AF is perpendicular to ED, so the angle between AF and ED is 90, and you can move forward with that understanding. Okay, that means that for your big shape here, the only angle you're left with is Z. You also need to know how many, for a 5-sided shape like AF, ED, FE, DC, AC, it's a 5-sided shape. What is the total amount of total angle measure of all the interior angles? So you remember the formula 180 times n minus 2, where n is the number of sides, 5. 180 times 3 is equal to 540. So the total internal angle measure of this shape is 540 degrees. So if I do 540, let's do this. So 60 degrees plus 90 degrees plus 135 degrees. All right, now let me just make it simple. I'll do it 45 plus 45 plus 135 plus Z is going to be equal to 540. If you just solve this for Z, you end up with 540 minus 60 minus 135 minus 45 minus 45. I end up with, so I got a very large number, which is 255. So I'm questioning if I did something wrong. Oh, I see where my mistake is. So you can't model this as a 90 degrees because both of these angles, while this is 90 degrees, both of these angles are much larger than 90. If that was really what you know is the sum of these two, if this was, let's just say 135 and 135, then yes, this whole thing is 90, which we know this whole thing is 90. So the sum of these two should actually be adding up to 270, not 90. Okay. So model them as 135 and 135. Again, just given what you know about these being perpendicular and these being parallel and these also having the same length, those two should both be 135. So let's revise this. 135, 135. So 540 minus 135 minus 135 minus 135 minus 60 is equal to 75. Okay, so Z is equal to 75. Let's write that in right here. Now, we know that this angle right here is 90. It says that means Y has to equal 15, and then you can solve X. So 15 plus 90 plus X is equal to 180. X is equal to 180 minus 15 minus 90, 75. And that's your answer. In the triangle below, what is secant of theta? So, or theta, sorry. So, sine, cosine, tangent, cosecant, secant, cotangent. Okay. These are all inverses of each other. So, cosine of theta is equal to adjacent over opposite, over hypotenuse. So secant of theta is going to be just hypotenuse over adjacent. And relative to this theta, I know the hypotenuse is 25. And my adjacent is 7. 25 over 7. All right, pretty simple. You didn't have to do any math there. Just got to know which one is which. Just to break it down for you, I will let you know sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. Tan theta is equal to opposite over adjacent. Cosecant theta is equal to hypotenuse over opposite. Secant theta is equal to hypotenuse over adjacent. cotangent theta is equal to adjacent over opposite. All right, good. It'd be good to memorize this. Just practice it on some triangles. So you can make some up or whatever. If any of these problems seemed helpful, and if you want more problems like this, just going through each skill one by one, not just for math, but for English as well. And also we have some bonus stuff on our website for reading and science. Be sure to check out the5academy.com. Our website has lots of content, both free and paid, for you to go through a lot of the skills on the test, do diagnostic quizzes, identify which skills you're weak in, and then take practice problem sets and get tutoring for those particular skills that you need work on. So if you want a personalized prep experience that tailors to exactly what your weaknesses are and what you need to improve to bridge the gap between your score and your target score, our program should be able to help you. So again, everything is linked down below. We have our free and paid programs down below. You can schedule a free tutoring session if you want to go that route, or you can access around 1,000 problems on our website, sorted by skill for English and math, and then additional problems for reading and science, which are part of our free bonus pack. Hopefully this was helpful. Let me know if any questions in the comments below, and we'll do our best to answer as soon as possible. Alrighty, see you guys.